Hello students, Jai Swaminarayan. I am Urvish Mewada, Assistant Professor, Electrical Department, Sri Swaminarayan Institute of Technology, Bhat, Gandhinagar. I am the subject matter of Testing and Commissioning of Electrical Equipment subject, which is in the 8th semester Electrical Engineering, and duty subject code of this subject is 2180901. Students, we are currently discussing the chapter number 3, that is Testing of Transformer, Plant and Equipment, and this is our lecture number 3. In lecture number 2, we have discussed in detail about a polarity test of transformer, in which we have discussed that why the polarity test is necessary, what are the arrangements we required to perform the polarity test of transformer, and what type of transformers means a rating of transformer that we should take to perform the polarity test of the transformer for the commissioning. And then after, we have discussed in detail the three-phase transformer connections, in which we have seen the two basic connections of transformers, say in star and delta, and then after we have discussed the different arrangements and phase groups of transformer for successful parallel operation, and different we can say connections that we established to get our desired voltage and current from the transformer. And then we have discussed the three-phase transformer connection. According to the connection, means if we use a delta connection, then what will be the output voltage and current of that particular transformer, and if we use a star connection, then what will be the output voltage and output current of the transformer. And then after, we have discussed in detail the three-phase transformer vector groups, in which we have discussed all four basics transformer vector groups, in which we have discussed a 0 phase difference, then we have discussed 180 phase difference, and then after we have discussed minus 30 phase difference and plus 30 phase difference. So this was the lecture number 2. Now this is our lecture number 3, in which we are going to study the topic number 7, that is equipment used to measure insulation resistance. So first of all, what is insulation resistance? So insulation resistance, basically it is a cover of we can say a conductor which transfer a current through it. So outer cover is called the insulation. And why this insulation resistance measurement is we can say necessary? So basically, insulation provides protection to the conductor, and if we place a conductor to which are near to each other, then it will provide an isolation between two conductors. So that's why the insulation is necessary. And let us discuss the equipments which we use to measure an insulation resistance of particular conductor. So let us discuss the insulation resistance measurement equipment in detail. So first of all, generally high resistance, which doesn't allow the flow of current through it. Basically, insulation resistance means it is a property of any material which does not allow a flow of current through it. So that's why the high resistance means if we are using this insulation for the protection purpose, or we can say it doesn't allow the flow of current, then the insulation resistance must be high of particular material. But it varies according to our requirement, means according to the level of voltage we use different type of insulation and different properties of insulation. So yes, generally the high resistance which doesn't allow the flow of current through it. So yes, to measure the insulation resistance periodically, it is necessary for long life of transformer and better operation. So yes, after certain use of transformer, we perform this test, or we can say when we purchase a transformer, at that time also we perform this test to check out the insulation resistance of winding. So that will be useful to check whether any short circuit is happened, or we can say if the insulation resistance is not proper, then we cannot use that device for our operation purpose. So yes, to measure the insulation resistance periodically, it is necessary for long life of transformer. So if we periodically measure an insulation resistance of transformer, then we can increase the life of transformer. Then yes, it is measured to avoid the short circuit between the winding, as I explained to you that if insulation of any material or we can say cable is degraded and number of cables are placed near to each other, then there might be a chances of short circuit. So yes, here we are talking about the transformer winding. So transformer winding is say having an insulation so that we can place a number of turns near to each other, or we can say by a particular winding. So yes, if insulation resistance of that cable is not proper, then there is a chances of short circuit between the windings in future after certain use of transformer, because when we use the transformer, heavy current will transfer through the winding, so that it will get heated up, and as the winding will get heated up, so insulation will also get heated up, and so that the property of the insulating material will get deteriorate after certain operation of the transformer. So that we need to measure the insulation resistance periodically, and so that we can increase the transformer life also. So yes, it is measured to avoid the short circuit between the winding in future after certain use of transformer. And generally yes, it should be in mega ohm. So as I explained that here we are talking about a large transformer, so yes, insulation resistance, advisable insulation resistance of this transformer winding is it should be in mega ohm or as per the capacity of the instrument. So yes, if the capacity of the instrument is large, then the winding resistance we must be keep in mega ohm, and as per the according to the voltage level and current level, we can set a particular insulation range, so that we can avoid any we can avoid an accident during the operation of the transformer. So that yes, it should be in the mega ohm as per the capacity of the instrument, and yes, it is a part of scheduled maintenance. So after certain use of transformer, it is a schedule that we have to check the insulation resistance of transformer. And generally we use different instruments to measure the insulation resistance of the transformer. So yes, the transformer insulation resistance for the measurement of the transformer insulation resistance, we use generally Megar. Megar is a name of company, but after the invention of the Megar, invention of this instrument, they named that device as a Megar. So Megar is an important device to measure the insulation resistance. And the second one is insulation tester. So let us discuss this two devices in detail, then how this will measure the insulation resistance of particular transformer. So equipment used to measure the insulation resistance. So this is the internal structure of the Megar, or we can say ohm meter. So over here you can see that between two magnets we are having a current coil and pressure coil, and it is having three probes. One is earth, second one is line, and third one is the ground. So the cable, or we can say for the conductor, we are measuring the insulation resistance that connect with the line, and second one is the ground, in which in between we are measuring the insulation resistance, and third probe will be earth. So yes, between two magnets we are having a current coil and pressure coil, and this is a small generator. So it is hand driven generator. So let us discuss this Megar in detail. So this figure shows the internal construction of Megar. Now in this small armature over here, it is rotated with handle. Before few years, we have a manual Megger, and in that the handle was provided on the outermost portion of the Megger, and that we have to rotate at certain speed to check the insulation resistance of particular conductor. So this is a manual Megger. Nowadays a digital Megger is also available. It is battery operated. So in this small armature which can be rotated with the help of our hand at the fixed speed. And yes, two moving coils in the field of permanent magnet of generator is given over here. So over here you can see that this is the pointer which is connected on the coil, and according to the deflection, this pointer will get deflected, and the scale of this instrument is from 0 to infinite. So these coils are attached in a T form. Over here you can see that this is the T form of the moving coil, and which are placed on or mounted on the spindle. Spindle is nothing but the movable portion of the meter. And the soft iron we can say cylinder is placed in the air gap to reduce an air gap. So yes, if the air gap is more, then this will offer the more reluctance, so that a soft iron cylinder is placed between the two magnets, and according to the rotation of the generator, the air gap will helps to the moving coil, or we can say control coil and current coil and the pressure coil for the particular movement. And this is what the air gap which helps to reduce the reluctance between the magnet and the coil, and the air gap which decrease the strength of coil increases. So as we reduce the air gap, then the strength of the coil will increase, means more amount of flux will transfer through this air gap, and so that the spindle will move, and the coil will get deflected, and the pointer will show the deflection accordingly. And one coil is called the pressure coil, which measures the voltage, and second one is the current coil. So yes, will measure the current which passing through the conductor, and the pointer which is attached on the spindle, or we can say this T formed coils, we can say coils which are attached on the T shape. The pointer is mounted on the T shape, and as this T shape will rotate as the according to the generated voltage and current, so that the pointer will also get deflected. So the pointer attached on the spindle which moves on the calibrated scale. So this scale is already calibrated, and according to the resistance offered by that conductor, this pointer will get deflected. And yes, the pressure coil is connected through high resistance. Over here, this is a pressure coil which is connected with the high resistance across the positive and negative terminal of the generator. So yes, this will protect, or we can say this will helps our Megger for the high voltage problem. So let us discuss the another we can say working function of this resistance which is under test. So this is the actual setup. For that we are measuring the resistance. So here between E and L one resistance is connected, and this is what the internal setup of the Megger that we have discussed. And this is the high resistance which is connected in series with the pressure coil, and this is the scale of the Megger from 0 to infinite. And the current coil and pressure coil both are placed between the magnet, and this is the generator that we are rotating with the help of hand at particular speed. So over here you can see that the CC which is connected across the this is the current coil which is connected across the negative terminal of the generator. So this is the negative terminal which is connected with the CC coil, and external terminal of the Megger which is marked E, which is connected through the current limiting resistance. So both are over here which are provided for the protection purpose. and the resistance which is under test for means the material, or we can say the element for which we are measuring the insulation resistance, which is connected between L and E. So yes, measure placed on a horizontal surface. This is the most important point that we should keep in mind while we are measuring the insulation resistance, and which is placed horizontal surface and handle rotated at uniform speed, say 160 rpm. So this is as per the standard that we have to rotate at with the help of hand. And yes, the armature which rotates through the gears. So yes, as we rotate the armature with 160 rpm, so it will generate a rated voltage for the measurement of insulation resistance. And yes, the generated voltage is about 500 volt DC, that will transfer through the pressure coil and the current coil and the element which is under test. So due to above, the current coil CC and it's inversely proportional to the resistance under test. So the current which flows through the CC means if the resistance is more, then the current which is transferring through the current coil will be less, and if the resistance is less, then the current transferring through the coil will be more. So over here you can easily understand that the current flows through the CC and it is inversely proportional to the resistance under test, and two currents or we can say two opposite torques, as we all know that flux is proportional to the means as the current flows, means I is proportional to the flux. So current flows, flux produce, and phi is proportional to T. So according to the level of current, the flux will produce, and as the more amount of flux will produce, then more amount of the torque will produce, so that the two currents that will produce the two opposite torques are produced and moving system deflects accordingly. So whatever the value of the resistance, according to that the current will transfer to the coil, and so that it will produce the flux, and so that it will produce the rated torque, and so that the coils which are placed on the spindle or we can say the T-shape iron core material is placed on the spindle will get deflected according to the torque produced in the coils. So when this two torques becomes equal, at that time the pointer deflection becomes steady. So yes, whenever there is a difference between two torques, then pointer will not get steady, and if both the currents become or we can say reaches at a equal level, then pointer will get will be steady. And as this pointer will become steady, so that we can say that both the currents which are transferring to the current coils are same, and this is what the value of the resistance that we are measuring, means the value of that resistance which is under test that we are measuring with the help of Megger. So this is how the Megger will work. And if the terminals are we can say short circuited with a simple wire, the maximum current flows to the CC and scale shows the 0. 0 means there is no insulation resistance, and so if we short circuited this two terminals E and L, then pointer will show the 0 deflection, because there is no we can say both the currents which are transferring to the coil are equal, and so that the it will not get deflected, and pointer will we can say remain at the 0 position. So this is what the Megger is. Now the second instrument, that is insulation tester. So let us discuss this insulation tester. For measurement of insulation resistance with the help of insulation tester, over here so in this insulation tester the insulation tester is a device. With the help of this insulation tester, again we can measure the insulation resistance of particular material. So yes, insulation tester is also used to measure the insulation resistance, but in this a high voltage DC is not generated like Megar. So in the case of Megar, we use a handle to rotate the armature, and so that the 500 volt DC will be generated, and from that 500 volt DC we can judge the insulation resistance of particular insulating material under test. So in this case, the high voltage DC is not generated in same as the Megar, but it generates the high DC voltage statically. So let us discuss that how it will be possible. So in this insulation tester, generally we use the battery to drive the oscillator. Oscillator is nothing but the device which generate the oscillating signals, and which is placed inside the insulation tester. So yes, high voltage AC will produce by an oscillating or we can say oscillator using the step up transformer, which we use, which is generally used inside the insulation tester. And yes, compared to Megar, an insulation tester measures an insulation more accurately, because in this case we do not have any oscillating fluctuating signal, same as as the Megar, because with the help of hand we cannot maintain the speed of rotation of hand, so that the generated voltage may get fluctuated. So in this case we will have the DC voltage, and which is static. So yes, in this case we can measure the insulation resistance more accurately compared to the Megar. And the tester is having 3 terminals, same as the Megar, so which are positive, negative and earth. And the cable whose insulation resistance must be measured is connected across positive and negative terminal. That is obvious that we had used in the case of Megar also. And earth terminal should connect with the earth point, where we are having a common earth of any system. And high voltage is generated by pressing the push button. In this we are having a step up transformer which produce the high voltage, and over here you can see that we are having only a push button, and by pressing this push button we can generate the high voltage, and the pointer moves accordingly and indicates the insulation resistance of the cable under the testing. So yes, this is what the devices that we use for the insulation resistance measurement. Now let us discuss the measurement of insulation resistance. This is the topic number 8 of this lecture number 3. So how we can measure the insulation resistance with the help of any device. So this is what the setup of the measurement of insulation resistance. Here we are measuring the insulation resistance in between the transformer tank and the conductor, or we can say live wire. So this is the line terminal which is connected with the line terminal of the transformer, and this is the earth point of the, or we can say tank is it is obvious that it is earth. So this is the second point which is connected with the earth point, and this is what the Megar is, so that we have discussed. So let us discuss how it can be useful to measure the insulation resistance for the heavy devices, or we can say large devices. So yes, it is the resistance between the conducting part and the earth. So this is the earth point, and this is the point where from where we can take out the terminals of the transformer through the bushings. Bushings are the insulating material, means the conductor which we are taken out from the transformer with the help of bushing. So generally bushing provides the isolation between transformer tank and the live wire. So yes, it is expressed in megaohm. So Megar is an insulation tester which are generally used to measure the insulation resistance that we have already discussed. And yes, it can be measured between the two phase windings and between winding and earth. So yes, if we measure an insulation between two phase winding, so it will show the insulation resistance between the two conductors. And also if we measure the insulation between the live wire and the earth, then it will show the insulation resistance between the live wire and the earth. That will indicate that there is no any live part of the system is grounded or not. So that will that can be checked with the help of this setup. So over here you can see that again we are having a current coil, pressure coil, and according to the motion of this armature, that this will produce a 500 volt DC, and that will transfer to the pressure coil and current coil, and according to the torque produced, that will this core will get deflected, and the pointer will show the insulation resistance of particular device that is under test. So let us discuss this how it can be measured with the help of Megger. So as we have discussed that we can measure between two phases, and we can measure the live wire and the earth. So let us discuss the first point, that insulation resistance measurement between the two phase winding. So yes, two conductors are the two phases which are connected with L and E terminal of the Megger. So line and earth terminal, between L and E terminal we connect two phases of winding, and that we have discussed. This point is again most important, that we need to place our Megger at horizontal form platform, so that the pointer will deflect smoothly, and the pointer will get from the pointer we can get the steady pointer will get the accurate reading. So yes, placed Megger on the horizontal form platform, and rotate the handle of the armature with the uniform speed, say 160 rpm, and reading of the Megger which shows the insulation resistance between the two phase in mega ohms. It must be in mega ohm, otherwise there might be a short circuit between the two phases. So the insulation resistance is measured between the two phases are like one by one. We can measure like between two wires and one conductor, and between each conductor. So yes, it can be measured between the other two phases respectively. So we are having three phase transformer, so we can measure an insulation resistance of each phase separately, and also we can measure an insulation resistance between two different phases. Now the second method, that insulation resistance measurement between the winding and the earth. So let us discuss how it can be measured. So L terminal of the Megger is connected to the line conductor of the transformer, and E terminal is connected between the earth. So reading is taken by the rotating the armature with the help of handle. The procedure is same. The connection that we have to keep in mind, that L must be connected to the L and E must be connected to the E. And when Megger is started, the leakage current IC, why this current is called IC? Because it is like a capacitive current. So capacitor is we can say a structure like a conductor, then we are having a dielectric, then we are having a conducting plate. So it is like the transformer. So over here we are also the same structure, the line wire, and then we are having an insulating material, that is oil, and the third point that is earth. So earth is nothing but the metal. So metal, then in inner cable conductor is metal, and between two metal we are having an oil. So that's why it is like a capacitor. So that's why the leakage current IC also flows with the leakage current IL. So this is what the measurement of these two methods. And the initial reading of the insulation resistance that becomes that can be measured with the help of R0, that is VDC by IL plus IC. So line current plus the charging current that will flows through the line wire and the earth point where we have earth our tank. So this is the formula from which we can measure the initial resistance, insulation resistance, initial position, and after 60 seconds of charging, current reduces, the current will be. So after 60 second we will again measure the resistance, so that is R at 60, so VDC by IL, so there will be a no charging current, so that's why after 60 seconds the charging current reduces, so that's why we can neglect over here. So the equation will become VDC by IL, and so the reading after 1 minute becomes more than the first reading. So why it is more? Because there is no charging current, so that's why the resistance will be more. For the transformer and big capacity machines, the reading must be taken after 10 minutes is taken, because after that we do not have a charging current. So that's why this is the important point while we are measuring the insulation resistance. And megers are available in the market, say in the range of 500 volt, 1000 volt and 2500 volt DC. And according to our requirement, we can purchase a megar and we can measure the insulation resistance periodically to improve the life of our device. And measure of insulation resistance of transformer. So to measure the insulation resistance of transformer up to 600 kVA capacity, a 500 volt megar is used. So this is according to the standards that we have to take the megar for the particular measurement of the transformer range 600 kV, and for all type of transformer 100 volt megar is used. So the type of transformer is dry type transformer, so there is no oil for the coolant. And for large capacity transformers above 11 kV, say 2500 volt megar is used. So this is what the range that we have to select for the measurement of insulation resistance using megar. And for two winding transformers, the following three readings must be taken. So that the reading that we should take to check the insulation resistance of particular transformer by earthing the HV winding and measuring between LV winding and the tank. So HV winding that we have to earth, and we need to check the insulation resistance between LV windings and the tank. And then after earthing the LV winding and measure the insulation between HV windings and the tank. So from that we can check is there any we can say short circuit between the tank or between the HV windings. And by earthing the tank and measuring between LV winding and HV winding, so from this all 3 points we can accurately measure the we can accurately check the insulation resistance between the conductor, or we can say of the conductor, and is there any leakage we can say happens or not, that we can check with the help of these three methods. So these are the methods that we use for the measurement of insulation resistance. Now let us discuss the topic number 9, that is temperature rise test of the transformer. So this test is again an important for the measurement of insulation resistance as well as for the long life of the transformer, because as we use a transformer for particular purpose, then as means the transformer is get loaded, so a heavy current will transfer through the transformer windings. And according to the given permissible limit, the temperature of the transformer should be increased, and if that will increase beyond the limit, then that will harm the inner parts of the transformer. So that's why we need to check the temperature rise test of the transformer to check the performance of the internal parts of the transformer, and from that we can improve the life of the transformer with the help of temperature rise test. So let us discuss this transformer temperature rise test in detail. So in this case of temperature rise test, let us discuss this temperature rise test in detail that we carried out to check the insulation level of the transformer, and that we check to maintain the insulation resistance of the transformer, and also to maintain to improve the transformer life. So let us discuss this test in detail. So yes, it is a type test. So we are having a different test, that is type test, routine test, and the schedule test. So this is a type of the test. That's why it is called a type test, that we are performed to check the level of the insulation and to check the life of the transformer. So it is performed only when it is found necessary. So how you can judge that it is necessary? So when the we can say efficiency of the transformer is reduced after certain used, so we need to perform this temperature rise test to check the insulation level and the working performance of the internal parts of the transformer. So let us discuss this temperature rise test. So from this test, the rise in temperature is found after the machine is run. So as we have discussed that as we run the machine for our load, so according to the change in the load, the current requirement will change, and as that heavy current will transfer through that winding of the transformer, the winding will get heated up, and so that the insulations which is surrounded to the winding will get heated up, and as the large transformers are oil immersed, so the temperature of the oil will also increased. So as the increasing of the temperature, the property of the oil will get deteriorate, means after certain use of the transformer, the oil will get heated up, and after means cooling and heating and cooling of the oil, the property of the oil will get deteriorate, or we can say it will become thin, and the insulation resistance of the oil will also get reduced. So yes, is run now from this test, that rise in temperature is found after the machine is run on full load for some period and constant temperature is reached, so that we perform in this test. So this is say called this is rise, or we can say, and the final temperature should be less than the limit that is mentioned according to the manufacturer, or as per the Indian standard, should be less than the limit of the class of the insulation, means the insulation that we have used surrounded to the conductor, and the insulation class, according to the insulation class, the oil which we use for the cooling purpose. So according to their temperature limits, we have to increase the temperature of the transformer. Now, why this transformer is necessary? So let's discuss the necessity of this test. So specific type of insulation is used in electrical equipment, and that can withstand the certain temperatures. So according to the class of the insulation that have a particular temperature withstand capacity. So as we have used an insulation inside the transformer, and after certain use, we need to check the quality of that insulation. So that's why it is necessary to check the level of the that insulation after certain use. So whether it is capable to withstand that much amount of voltage after certain use as initially. So that we have to check with the help of this temperature rise test. And if the temperature produced in machine is more than this temperature, means according to the desired level of the insulation will get damaged after certain use, and short circuit occur after some period of the machine becomes useless. So as I explained that if the inner temperature will increase beyond its limit, then insulation will get fail, and there will be a chances of short circuit between the live parts of the transformer. So it is necessary to know the effect of the temperature on the insulation, or you can say insulation of the temperature rise, that we need to check. So this is what the necessity of the test. Now let us discuss this how this heat run test is been carried out to check the insulation, or we can say performance of the internal part of the transformer. So the another name of this test is heat run test. Both are same, in your GTU exam, examiner will ask that temperature rise test, or we can say heat run test of the transformer. Both are same. So let us discuss the setup of this transformer first of all. So this is again also called a back-to-back test. So over here you can see that a transformer which is connected over here, secondary of primary of the transformer is connected with this primary of all the transformer over here, and secondary which is connected with the primary of the other transformer. That's why it is called the back-to-back test. So over here you can see that we are having an emitter which is connected in between these three transformers. So let us discuss that how this back-to-back test is been carried out to check the insulation level of the transformer. So two identical transformers are necessary for the test. Identical means the turns ratio and the voltage ratio must be same of both the transformers. That's why it is called identical. So back to back the transformers which are connected over here as per the diagram, if we can see that. So secondary winding of one transformer is connected. This is the secondary which is connected to the secondary winding of another transformer. So over here you can see that this is P1. P1 is indicating that this is primary, and this is the P2, and this is the P3. This is what the secondary. So secondary of this transformer which are connected to each other. Over here you can see that. So they are connected with the winding of the another transformer such that they are in phase opposition. So whenever the flux will produce, that will oppose to each other according to the placement of the transformer which is shown over here. Now primary winding of the second transformer connect with the source. So this is the transformer which is connected with the source. Now secondary winding of the auxiliary transformer, this is the auxiliary transformer, is connected in secondary loop. This is the secondary loop, and auxiliary transformer is of the step down. So step down transformer means that the turns of the secondary will is less compared to the primary. So auxiliary transformer is of step down transformer which energized through the auto transformer. So this is the auto transformer, and with the help of this auto transformer, this transformer will get energized. So let's discuss this how this test has been carried out in detail. So current is circulated in the secondary loop with the help of auxiliary transformer and auto transformer. So by varying the number of tappings of the transformer, we can give an energizing voltage to the auxiliary transformer, and the value of above current is adjusted so that the full load value. So according to the full load value, we'll adjust the level of the current by adjusting the tapping of the transformer, and temperature of an oil and winding are measured with the help of transducers or other suitable method. So over here we are having a closed tank, so we cannot use thermometer over here, so that generally we use temperature gauge. In temperature gauge we are having a different transducer devices. So transducer is what the device which convert the physical energy into the electrical energy. So that transducer will measure the temperature in terms of electrical output. So from that we can measure the inner temperature of the transformer, and in this test, power required to overcome the losses of the transformer is drawn from the supply, even if the transformers are operated at full load. So when the transformers are operated at the full load to reaches at the we can say level of the given output voltage, or we can say the input output ratio of the transformer according to the value that we have to that we are giving in the input side of the transformer according to the level of the voltage or rated voltage of the transformer. So that we will check that we will get from the primary, or we can say the transformer which is connected with the source. So yes, the required the required power to overcome the loss that will that we will drawn from the transformer which is connected with the with the load. Now this method is economical and widely employed for the large capacity of the transformer to check the temperature, or we can say insulation level of the transformer. And the method which used to measure the temperature that we are going to discuss in detail. So thermometer can be used, but it cannot be reach the conductor, so actual temperature for the winding cannot be obtained. So that can be obtained with the help of transducers only. So yes, transducers are used to measure the accurate temperature, and the transducer basically which we use to measure the temperature, say thermistor or RTD. So thermistor is having a NTC property, negative temperature coefficient property. So as the temperature increase, the resistance of the device will reduce, and RTD is having PTC property, positive temperature coefficient. So as the temperature increases, the resistance of the device will also increase. So these are the devices that we use to measure the internal temperature of the transformer, and they are kept at the required spot where we are getting a maximum temperature, and the leads which are taken out and which are connected to the suitable measuring devices, and or we can say converting devices to measure an accurate temperature. Now the output of the transducer is proportional to the temperature inside the transformer. That is obvious that we have placed our transducer to measure the internal temperature of the device, and that can be achieved through an electrical circuit, and temperature is indicated on the scale. That for that we are having different signal conditioning devices that will condition the signal according to the requirement, and that will show the reading of the internal temperature of the transformer in terms of the scale, movement of the scale. Now rise in temperature can be found by finding the rising the resistance of the winding. So as the resistance of the winding will increases, we can say that the current which is transferring through the conductor will also high, and as the resistance winding will and as the temperature of the winding increase, the resistance of the winding will also increase. And this method can be employed only to small and medium capacity machines. So resistance of the conductor increases with the rise in temperature. It is obvious that it is called PTC, means positive temperature coefficient, that we have discussed earlier. And if over here one case is given, that if we are having R1 ohm and R2 ohm are the resistances of resistance at temperature T1 and T2 respectively. So for T1 temperature we are having a resistance R1, and for T2 temperature we are having a resistance of R2. And if the alpha 0 is the resistance temperature coefficient of the conductor at 0 degree centigrade, so this can be related by the relation that is shown over here. So T2 is equal to T1 plus R2 upon alpha 0 into R1. So where T2 is the temperature of the resistance 2, T1 is the temperature of the resistance 1, or we can say the condition where we have not applied any voltage to the device. At that time temperature is T1, and when we have actually give the rated voltage and current to the device, then the temperature of the device will increase, so that the temperature of the winding will also change. So it will reaches to the T2, and R2 is the resistance means at the point where we are having a transformer is actually loaded. Alpha 0 is the temperature coefficient at 0 degree, and R1 is the initial resistance. For copper value, alpha 0 is the value of the alpha 0, it is standard, that is 1 upon 234.5. So let us place these values in the given formula. So T2 is equal to T1 is equal to R2 minus R1, and we have placed alpha 0 with the 1 upon 234.5 R1. So therefore the T2 is equal to T1 plus 234 into R2 minus R1 divided by R1. So this is the expression. Sometimes alpha is used instead of alpha 0, due to which there is an error of 8 to 10% during the operation. So during this test there might be a chances of generation of the error, say 8 to 10%. So for that we can use different temperature coefficient for different temperatures. Say instead of alpha 0 we can use the alpha 1, according to the chances of error. So this is what the lecture number 3 is. So if you have any query or doubt related to this topic, then we can solve your queries and doubt in our doubt solving session. Also feel free to call me to solve your doubts and queries related to this topic. And this is our lecture number 3. Now then the next topics will be discussed into lecture number 4, and the assignment which is related to this chapter that I will give you in the last lecture. So for that, stay tuned. Thank you very much, student. Thank you all. Jai Swaminarayan.